Welcome to Chemical Bonding. My name is Dr. English. Today we're going to focus on metallic bonding. Specifically, we're going to look at what is metallic bonding, a sea of electrons, examples of metallic bonding, physical properties of metallic elements, and finally, 2 practice problems. So what is metallic bonding? The electrostatic attraction that occurs between the positively charged atomic nuclei and the free-moving valence electrons in the metal. So, translation, you have a nucleus, it's positive, and you have electrons that surround that nucleus. It's this force of attraction and how the electrons behave within a metal that makes it unique. During metallic bonding, valence electrons are in constant motion and move from one atom to another. Such electrons are not associated with any specific atom and move freely throughout the metallic substance. These electrons are called delocalized because they're not local to a specific nucleus, or non-localized electrons. Let's talk about the term sea of electrons. Metallic atoms, which have a few valence electrons, not a ton, but a few valence electrons, and low ionization energies, cannot achieve the noble gas configuration by traditional covalent or ionic bonding. Instead, atoms of metals in a fixed crystal arrangement achieve a more stable electron arrangement by sharing their valence electrons among themselves in a mobile sea of electrons. So we're not transferring electrons, we're not sharing electrons. All of our electrons are just moving very higgledy-piggledy, which is an extremely scientific term, all over, surrounding these different nuclei, and as a result, in this sharing of electrons between all these different nuclei, it becomes really stable. Yeah. So electrons do not belong to individual atoms, but rather the metallic crystal as a whole, and it works. It works for metals. Some examples of metallic bonding. Metallic bonding exists in metals such as copper, iron, and aluminum. Metals are commonly found as solids at standard temperature and pressure, otherwise known as STP, due to the strength of the metallic bonds. The exceptions to these are mercury, which we can see right here, which is a liquid at room temperature, and gallium, which have extremely low melting points. Physical properties of metallic elements. Metals typically have luster, which means that they're shiny. They're malleable, which means they can be pounded into thin sheets. They have ductility, which means they can be drawn out into thin wires, ductwork, pipes. They are conductive. They can conduct an electric current. If you've ever been shocked by a metal, you know exactly what I mean. And they typically, not all the time, but they typically have high melting points. So let's look at 2 practice problems. Which statement best describes the type of bonding that exists in a sample of solid titanium metal? Our choices are A, covalent bonding, B, dispersion forces, C, hydrogen bonding, D, metallic bonding. So what I'd like you to do is stop, make a selection, come back, and see how you did. Welcome back. Let's see how you did. So we know this involves a metal. So covalent bonding is out because covalent bonding typically occurs between 2 nonmetals. You, to this point, have never heard of hydrogen bonding or dispersion forces, so not an option. Oh, I don't know it. That's the one I'm going to pick. No, don't do that. Instead, we're going to go with the one that has metallic bonding in it. So titanium metal, yes, it has metallic bonding in it. Let's look at our next practice problem. Which substance contains metallic bonding? So again, stop, make your choice, come back and see how you did. Welcome back. Let's see how you did. So we have germanium, iodine, phosphorus, and thallium. You should have crossed out iodine and phosphorus immediately because those 2 are nonmetals. And then germanium is a metalloid, so that's not going to be an option either. Instead, we're going to choose thallium, which is definitely a metal on the periodic table if you took the time to look it up and look on table S and say, gosh, I wonder where thallium is, find the atomic number, locate it on the periodic table, and then you're like, hey, look, there's thallium. So what did you learn? We talked about what is metallic bonding. We referenced the term a sea of electrons. We looked at some examples of metallic bonding. We talked about the physical properties of metallic elements. And finally, we did some practice problems at the end. Need more help? Feel free to contact me. Have a great day.